And we are recording. Start Zoom recording. All right, testnet check-in, bug debrief.
Sorry, this was, I had put this in. I thought it would be useful to, and maybe I think between all of the different bugs and PRs that were closed, I think for someone from looking from the outside in, there isn't like a single place where, we just like talk through what was the bug, the fix and the whole process. I thought it would be a useful exercise, both for us and for like just with the community. I think the Discord channel was also made well readable kind of, midway through that whole process. So this is mostly a suggestion just to see if people thought it wouldn't be useful to put together a quick write-up and just share it with the community.
Yeah, that sounds reasonable. Let me go ahead and put an action item for that. Can't spell. How spell postmortem?
I think it's M-O-R-T-E-M. I think you had it right the first time, but it's not English. So.
Yeah, can't rely on my spell check. All right, can go ahead and write that up after this. But there isn't an issue open right now in GitHub because we were kind of, I don't know, in a state of near panic trying to fix it all week. But the high level idea, just in background, is that when you calculate the root hash of a trie in the marf, that root hash is not only the hash of its immediate children, but it's also the hash of a skip list tower of previous tries. The reason being is that each trie then commits to the state of all of its ancestor tries in this manner, in such a way that you can make a compact proof that a particular key exists in a particular ancestor using that authenticated skip list. The difficulty we encountered with this bug is that we made an optimization a while back when we were profiling the marf to ensure that when calculating that root hash, we didn't have to continuously look up the ancestor trie root hashes. Because doing so while it takes log n steps, where n is the number of tries in the marf's list of ancestors, and just the disk IO itself can make this expensive. So we made a one-off cache inside the trie file storage that, given the current ancestor's root hash, will give you the list of ancestor root hashes that you need to hash to calculate the current root hash. The problem is that this cache wasn't getting cleared if we tried to process a block that was invalid. So the act of rolling back an invalid trie did not clear this cache into storage. This normally wasn't a problem and didn't show up in any of our tests, because if you then produced a valid sibling block of the invalid block, it has the exact same ancestors as the invalid block. So using that stale cache data wouldn't cause inconsistencies. The problem that we encountered on testnet was that somebody was mining invalid blocks that were not siblings, but were great uncles, basically, of the next valid block. So they left the cache in a dirty state, causing the next valid block that was a distant nephew to use the invalid cache state and lead to a state root mismatch. This could not be duplicated using just the chain state locally, because that cache would be properly reloaded, A, and B, the Stacks node does not store invalid blocks. It garbage collects them. So we had no way of even seeing the invalid block. We just knew that there was somewhere someone was producing an invalid block. Trying to identify that problem took a while, as Aaron pointed out, because we didn't have debug symbols for the longest time, or didn't have proper debug symbols. And after that, there was this whole problem of finding the right version of GDB that could read the debug symbols, because it's a relatively new feature in GDB, one that does not come with a built-in debugger on Debian Stretch, for example. Aaron, I think, ultimately deserves credit for discovering the bug, because he managed to show how the cache could be used to produce an invalid marf trie. And then I was able to take his test case and turn that into a higher level test case that used a sequence of invalid blocks to reproduce the error locally. And then after that, the fix was pretty straightforward. You just clear the cache whenever you roll back from an invalid block. Does that all make sense?
Yeah, thank you.
Mm-hmm. I'm happy to write this up and post it in the Discord afterwards.
Yeah, thank you. I think that'll be useful. Yeah, I just added the rest of the bullets here just as talking points for things to go over. There was another thread panic, I guess, yesterday when the chain reset itself. Ju, do you have more to share on that? Like, was this known issues, a new issue? I know you sent out a PR to fix it as well.
So the generally speaking, when it comes to storing data in a MARF indexed database, there's two parts of the commit process to make the data persistent. You have to store the actual values that are being indexed, and then you have to store the new try in the MARF and make that persistent. And we actually have two ways of doing this right now in the code. There's the one inside Clarity, which does all this inside the marfed KV struct. And it correctly commits the values and then commits the index. These live in separate databases, so this is not done as a transaction. It's simply done as two transactions, one after the other. In the chain state and in the sortition database, and this is has been an open issue for some time. It just has never been a problem until just now. We just got lucky with it. We store the index state, and then sometime later we commit to the values. Reason for that was just the reason for that was just because at the time, this is like before we stored the try in SQL, and also at the time we didn't have to worry about multi-threaded access. It just seemed like the code just flowed better that way, but it's unfortunately incorrect nowadays. What had happened, at least what I think happened based on the logs, is there was a race between the sortition database and the peer-to-peer thread, where the sortition database committed its index state but not its values, and in between those two periods, those two events, the peer-to-peer thread processed a block pushed to it for a burn chain block whose marfed database keys existed in the committed index, but had not been stored yet to the marf side storage. This led to a runtime panic because it should never be the case that a key in a marf doesn't correspond to a value in its side storage. My PR fixes the commit logic to do what the Clarity database does, which is commit the values and then commit the index. Does that make sense?
Yeah. We can ignore this next bullet. There's just something that I've noticed over the weekend. So this is between the reset on, I guess, like Thursday and the reset on Sunday. I noticed the block production rate had been much lower than sort of prior iterations of Argon. But since the reset last night, it seems to be back within what the numbers that we were observing before, so might be a non-issue. So we can ignore that for now.
We can take a look at it later. If it is the case that somebody is still out there producing invalid blocks, this could be a symptom consistent with that. If the logs will tell us for sure. It's just we hadn't been seeing this, for example, last week because the testnet kept crashing from it.
Mm-hmm. And then this last bullet is Hank posted on Discord on the testnet channel that he had a couple of transactions. These are after the reset last night. So these are, I think, contract call transactions that have been in pending state for hours now. And I couldn't find anything in the logs. So just wanted to post it here so we can at least take an action item to look at it afterwards if no one has looked at it yet.
Yeah, sure thing. I suspect there was a regression somewhere in the miner that led to the invalid block production, and that might also be causing this. But obviously, we'll have to take a look to know for sure.
Okay. I'll just add it to the action item here.
Go ahead and, yeah, just add this.
Oops, sorry.
I'm sorry. All right. Oh, oops. let's look at our current milestones here. So we had this sprint, I'm sorry, it's due today. Clear that one. So I know that I'm actually, so unfortunately to Walker, a lot of things were basically paused this past week due to the catastrophic bug that we had to drop everything and fix. I still am not finished reviewing Ludo's PR. I'm actually kind of confused by a couple things still, but I can reach out and get this done today, before the end of the day. Does that work for you, Ludo?
So I was thinking about that, and I think that Aaron have been basically revamping this code. So I wonder if we should just close it and just evaluate.
I'm sorry, I didn't quite hear that, Ludo. Can you say again,
Aaron, that will. No, can you hear me now?
Yeah, I think you're just far away from your microphone.
Can you hear me?
Yes.
Okay. Yeah. So I was wondering, should we close this PR and just evaluate the PR from Aaron's that will be basically unstubbing the code and yeah.
Yeah, I was gonna suggest that as well, because like the PR I'm gonna open sometime in the next couple days, hopefully. Basically, it's built off of both Ludo's PR and Jude's POX refactor PR. So in a certain sense, it subsumes them, but it also it answers the question of how you review the stubbed code because it unstubs all of them.
Ah, got it. Sorry, is this a PR or is that? Yes, this is the PR. Okay.
I think that's the issue. I don't know. The PR is like maybe that link.
Yeah, let me get this open here.
Maybe not.
Well, I'll just add it here then. I mean, go back and do the PR. Still can't spell this morning. So should I go ahead and close this then, you think? Or do you still find it valuable?
I think so, yeah.
Yeah, though I think this might be an issue. I think we shouldn't close the issue quite yet.
Yeah.
Yeah.
Sounds good.
We'll figure out how to manage closing the PR. That's fine. This I think we can close because there's not really going to be a proof of transfer database anymore.
Okay. All right. Cool. So this, I think, Aaron, you approved, and I think I'm just still waiting on Ludo's approval.
Okay. I take care of it today. Yeah.
What's up?
Okay, I'll do the review today.
All right, sounds good. Thanks. This PR right here, I think Aaron also reviewed. It's all it does is it removes 2 of the steps in the public IP discovery that were causing this entire protocol to fail in full cone nets. It's opened against the chain state PR that I have in order to make it smaller and easier to read. But yeah, if we could get that reviewed and merged into the chain state PR, that'd be great.
That's good.
Cool. And same goes for this one. This is just a small PR that implements the burn block height clarity variable. I'm finding this is necessary for the POX lockup state.
Yeah.
And it's also opened up against the chain state PR. Still waiting for Ludo's review. In progress. How's the string type support going?
So it's done. So I need to implement more tests and maybe try the PR, the code, but yeah, it's there. So I think I'll be opening a PR either today or tomorrow.
Awesome. I'm just going to go ahead then, bump the milestone, and then we can just have it open the first day of this milestone then.
Yeah.
And let's see, change coordinator. I think we just decided this is going to be superseded by Aaron's PR.
This is the issue for that PR that's going to do the super session.
Excellent. So go ahead and push that milestone.
Yeah.
And I saw this. How are we doing on this, Aaron? Is this ready for merge?
Yeah, I think it's it's ready for review. I want Ludo also to just take a look at it.
Okay.
Yeah, so this just adds the Bitcoin D integration test as a GitHub action step. Yeah, I have a little comment in there that it's a little strange to do testing in GitHub Actions because they don't support like natively canceling redundant tests.
Do you think there's a way? So I guess I'm kind of curious, like why we're not doing this as part of Circle CI.
I wanted to see if I could do it in GitHub Actions easily, like just as like basically a test case for doing these kinds of things in GitHub Actions, because I've become increasingly annoyed by Circle CI over the time that I've used Circle CI. But like this could be converted pretty easily into a Circle CI test because really all it's doing is just running a Docker file.
So the only hesitation you have for using a GitHub action is the fact that you can't cancel a currently running test case?
Yeah, not easily. There's like people that have built like GitHub Actions to do the cancellation. So like there's like kind of libraries for doing automatic cancellation, but I don't know.
Seems strange they don't do that.
Yeah.
Can you SSH into the container running this test case if it fails?
I don't think so. I think you just get the log outputs.
Yeah, that's probably like too much low-level infrastructure that GitHub is never going to expose.
Yeah.
The reason I ask is that's been kind of like in the rare case where something is not reproducible locally, but it constantly happens in Circle CI. The ability to SSH into a container has been a godsend.
Yeah.
Even though Circle CI is a little bit more annoying, I agree.
Yeah, I mean, I can convert this into a Circle CI action if you all think that would be preferable. One of the things that is nice, like, I don't know, this thing runs in about like 10 minutes on GitHub. And I think as a Circle CI action, this would probably be like 30 to 40 minutes just because like the images, or the VMs that we're running in Circle CI are pretty tiny. So I think if we are going to go with Circle CI long term, we should think about upgrading our Circle CI infrastructure.
Yeah, I mean, I think ultimately we will want to do something like code coverage testing again, even though we OOM trying to do that right now, like just to make sure that we're not omitting any glaring pieces of code when we commit stuff.
Yeah, I agree. Like basically the issue that we have with Circle CI is like our images like max out at, I think it's like 2 gigabytes of memory or something.
Oh yeah, that's pretty tiny.
Might be 4. Like we OOM doing like release builds of the test cases. So like if we ran cargo test with the release profile, it would OOM.
Yikes.
Yeah.
Is there a, is it straightforward to upgrade our Circle CI? I mean, we're on the free tier right now, right?
So I can take that as an action item. Like upgrading Circle CI is easy, and if that's like a quick solution to some of these problems, we should do that. There might be like a good argument to be made that maybe we should switch to GitHub Actions, but I don't think we need to make that decision right now or have that conversation right now either. So the team feels like upgrading Circle CI is the easiest thing to do, and that would address some of these things. I'm happy with that.
If we do upgrade Circle CI, something that we certainly need to do is impose time limits on our tests again. Because like right now, if we get into this like infinite loop sort of condition, failing condition in a couple of the like block downloader tests, I think, where like the network never reaches stability. Basically what happens is like the tests time out after 3.5 hours.
Yeah, that's not okay.
Yeah, and if we were paying for those credits, like that would suck.
I will look into doing that as a precondition of upgrading our Circle CI VMs then. There isn't a way to do it natively, I've discovered. You have to patch it in yourself, but it looks like it could be done.
Yeah.
Yeah, there's some of the, I guess, like other actions that people have mentioned in the forum thread that you linked, Aaron. They seem promising. So if we do want to move forward with GitHub Actions, I think the auto cancellation is a solvable problem fairly easily.
Yeah, I think it's a solvable problem. It just requires a little bit of solving, basically. So yeah, I think we should think about what direction we want to go, because there are actually a lot of things that are way nicer about GitHub Actions.
I didn't mean to suggest that we should do one or the other.
GitHub Actions, like the images that they're running in are like behave way more like a standard VM image than the Circle CI containers.
Cool. Maybe we should talk about this more at the architecture meeting.
Yeah, I think that's a good idea.
Cool. Backlog. Any of these? Aaron, I think you mentioned something earlier about this being bumped to the next issue, or what do you want to do with this?
I don't plan on looking at this until after POX implementation is basically done.
All right, I'm just going to kick it by 2 milestones then. Sound good?
Yeah.
All right. And associated chain tip to mempool TX is sent to the sidecar. I think this is just a matter of updating the transaction receipt format.
Yeah, untouched. I should be able to take care of that this week.
All right, cool. Alrighty, let's go ahead and your milestones. And look at our new issues. All right, this is the PR I just mentioned that fixes the Git calls to commit. That removes the need to do a separate index commit. This PR should be taken as a preliminary fix, because there is a bad path that has quadratic time complexity that we are currently not hitting, but simply because we've been careful. But nevertheless, this could be re-architected in the future. I just didn't want to do that right this second because it would be a somewhat bigger change. Regarding this issue, one thing we could pretty easily do, and I'll fold into the chain state PR since it's like a 3-line fix, is just to make it so that if the testnet does panic again, we'll get a core dump from it. I think that would be just a useful thing to have, especially because panics, there's no process to GDB into in the event that the system does panic. It seems pretty straightforward to do. You just need to catch the panic and then give the process a sig quit to itself, and then make sure that your core file limit is unlimited. I can take that on this week. Speaking of testnet, one of the lessons learned, I think, from the recent struggle trying to figure out the try ancestor cache and why it was dirty is that we did not have a way to systemically replay a production node's chain state to see if anything went wrong or to see if there's any behavioral changes, and B, we don't retain invalid blocks. The former was fixed as a means to trying to solve the caching problem, but the latter, saving invalid blocks for future reprocessing, is something I think we should turn on, or at least have a feature for testnet, so that this sort of thing will become possible in the future. I'm happy to take this on as well. It shouldn't be that big of a change. It's just a matter of not erasing the file, the block file. We can just put it into an invalid directory or something, so that at least we'll have it, instead of trying to log it in the log files the way that we currently are. So Pascal's been busy over the weekend. He sent us a PR that implements more of the miner reward feature. Right now, the miner reward is locked up in a Clarity smart contract. Sorry, I'll scroll back up here so you can read it. It's locked up in a Clarity smart contract that is gated. So you can't just withdraw your miner rewards because A, the contract isn't complete, there's no stacks backing them, and B, at the time the code was written, we thought we would need to KYC miners before we let them withdraw their stacks. That is no longer true, to the best of my knowledge. Miners can just claim the rewards directly. So part of what Pascal is currently working on is just eliminating that feature right now of requiring a smart contract to hold on to miner rewards. Instead, the rewards will just be granted directly to the miner's address once they mature. I need to review this PR and hopefully get that merged in. That would be pretty cool to have going forward on the next chain reset. All right, I think we just talked about this. This is the testnet Bitcoin. This issue from Pascal, I think, warrants more investigation. I think this is part of the problem we noticed on testnet, not producing blocks as quickly as we would like. Pascal did a really good analysis here of looking at the parent-child relationships between blocks from testnet, and showed that there were a lot of orphaned blocks, and it's probably because the miner doesn't do a good enough job making sure that blocks are built off the latest chain state, and or ensure that the node has the latest chain state by the time the miner starts working.
Aaron, you and I had discussed this briefly. I think the visualization that you did also demonstrated something similar. And at the time, I think I recall you saying something about, our short block times might also be exacerbating this problem. And so increasing the block time on the testnet might help alleviate some of that. And then we kind of want to edge towards that anyways. And then if I recall correctly, in that discussion, we kind of said that sort of micro block functionalities, like it might also be like a good forcing function to start exercising micro block functionality.
Yeah. So if you look at the basically the visualization of what's going on with the blocks, what you see is like one sort of trunk chain with like a couple short-lived leaves off of it. Those are reducing are sort of like good put in terms of like incrementing stacks height. And those are probably caused exactly by the short block time. Like if we had a longer block time, people that are caught up with the chain would mostly be all mining off of one trunk. And yeah, so if we pushed our block time up, that would help. And also force us to exercise microblocks. The second like pool of blocks that are getting orphaned a ton is that like when somebody starts their miner up, there's like a period of time during which they have all of the Bitcoin blocks, but they don't yet have all of the Stacks blocks. And their miner is still sort of running. And so they're like mining off of just super old blocks, or they mine a new Genesis block and all sorts of things like that. So if you look at like the visualization, you'll see some like weird clumps like in the middle of the trunk where there's like a ton of orphans, and also just like a giant pool of blocks that are like mining their own Genesis. So dealing with that is a little harder. I think that we have a different issue discussing that. There's like a heuristic issue about like whether or not you're still downloading Stacks blocks at like a high rate.
Yeah, once we close that issue out, I think that that latter problem you described will go away. Aaron, do you want to reply to Pascal and maybe share your visualization?
Yep.
All right. I wrote this up last week sometime. I think this came out of the last architecture meeting we had. What the difficulty I was facing when working on the POX lockup state is that SIP 007 is ambiguous about what's supposed to, what the stackers are supposed to commit to in terms of what chain tip they write into their transaction. The reason this is difficult is because the stacking transaction has to get confirmed before the anchor block is confirmed. So the stackers have no way to pick an anchor block. If they send their stacking transaction via the Bitcoin chain, that would happen in the registration period, which is after the anchor block. So there's a chance there. But this is still kind of risky because if we find ourselves trying to pick an anchor block via behavior that the stackers can do, no, I'm sorry, that part's fine. The problem here is that the security guarantee that we mentioned at the end of SIP 007 about how you can only get a deep chain reorg due to missing anchor blocks if a mining cartel is able to produce an 80% long fork and B, censor the anchor block, and C, they have to also control enough of the liquid stacks that they can permit stacking to go forward, blessing an unknown anchor block. Guarantee part C here is not holding in practice because the stackers have no way to pick an anchor block right now, just due to the fact that the anchor block must come after the stacking transaction. So what this proposal does is it tries to recover that property where if an insufficient number of stackers don't bless the anchor block, then POX does not happen. And the way that it solves this problem is by making it so that stackers can repudiate an anchor block that miners confirm by explicitly rejecting it. And if over a certain percentage R of the locked stacks rejects it after the stacks are locked, then the POX protocol reverts to proof of burn protocol. I don't know what a good value for the rejection fraction is, but it would need to be high enough that somebody can't just, like a rich person can't just grief us, but it must be low enough that there's a chance that this will work. And the way that which we would, sorry?
And then these also need to be Bitcoin transactions?
I think that can be either. So what would happen in the rejection phase, in the rejection path, this would be a 2-transaction operation per stacker. The stacker would lock their stacks up, and then during the registration period, they can vote to reject the anchor block.
Right. The problem is that basically we want this property that you don't read anything from the stack's chain state after the anchor block.
Yes. So yeah, they would need to be Bitcoin transactions then.
Yeah, which I think is fine, because like this is such a, like the way that we should think about this is that this is like a very rare activity, right? Like submitting rejections is not something that you would expect to occur frequently.
Mm-hmm. What I also like about this proposal is that it gives us the kill switch mechanism that we need to ensure that POX can at least potentially be incentive compatible. Because if we see miners start to band together and start to discount mine by ensuring that they and only they can stack, this at least gives stackers, i.e. not the miners, the ability to shut down proof of transfer so that miners don't get their discounts. And they can do that. They can do this at any time, and they can do this for any reward cycle.
Yeah. Yeah, I like this approach. Yeah.
Okay, I'll go ahead and start implementing it as part of the POX lockup PR that I'm currently working on.
Right.
I think this is the issue you mentioned earlier, Aaron, the need to track the block download rate in order to ensure that we don't start mining too early. Do you want to try to take this on, this issue, in this epoch?
In this milestone?
Excuse me, yeah, milestone.
Sure. I mean, I'm not sure whether or not I would get an opportunity to take this on, this milestone.
I would say, like, unless there is a blocker for POX, we shouldn't even try.
Okay, we'll just leave it unassigned then. It's not going to kill us if we don't fix it right now. I just want to make sure real quick that this is assigned to a milestone. I'm going to take this on for this milestone here. UPnP support, I think this was last week. Oh, how'd that open? So one thing that would be, this is a nice to have, we don't have to do this anytime soon, but we could solicit the community for help, is to implement enough of the UPnP protocol so that a Stacks node can automatically set up port forwarding for itself on a home NAT and thereby start serving blocks to the greater Stacks network.
Yeah. Yeah, this would be nice to have, and I think it's good help wanted issue, but
there's no priority.
We should probably move this out of new issues into like Icebox or something like that. Like some issue, yeah.
Fair enough. Enforce 10-minute timeout on all tests. I'll take that this week. There's not a way to do this in the native test framework in Cargo, unfortunately, but I think I can make a procedure macro decorator that will just do it for us.
Really, there's no way to enforce timeouts natively?
Not in the native test framework, no.
Wow.
Because there's not, I mean, I can see why the maintainers have justified this, saying it's trivial to implement a macro that does it for you, so there's no need for the framework to do it. So I'll just go ahead and adapt that. I think I already talked about this one here. And I think we're at the end of our issues here. We have this timing out test, for example, but the timeout itself will go away with the timeout fix. And I've been trying to reproduce this locally, but I just haven't been able to yet.
Yeah. hopefully adding the timeout will make it like more clear when it is the failing one.
Yeah, we might even be able to push it to like 5 minutes or something, because when these tests pass, they don't take that long to pass.
Right.
There's only a handful that take more than 5 minutes in the correct path. And even those are pretty long. I don't know. All right, cool. I think we're through with the new issues. Nothing in Icebox anyone wants to talk about?
I don't think so.
Nothing in the backlog?
Unrelated, and we don't have to do it in this meeting, but I don't know if people are watching, like there have been a bunch of like issues that were marked stale by the Sailbot that have since been closed. I think a lot of those issues have actually been implemented or addressed, or have been duplicates of other issues that have been since created. So I think we just need to go through and just do like a cleanup. So I'm happy to make a first pass. I'm just looking through older issues, reopen anything that still needs to be open, and try to link issues that have been duplicated. But just wanted to flag that we have had a bunch of stale issues that have been closed recently.
Yeah,
right.
Yeah. I've been trying to like, I'll remove the stale tag on issues that like I don't want the stale bot to just close.
Yeah.
Some of them I just allow it to. Just sort of silently say like, yeah, stale bot close this issue, force the topic.
Yeah, that sounds good. I can do it pass after you, DeWalker. All right, testnet timelines. So speaking just for myself here, all of this is pushed back a week for me, just due to the testnet crisis we dealt with last week, because I worked on nothing else.
Yeah, I'm pushed back. I don't know, probably a week as well. I don't know how much longer the integration of all of these POX changes with the chain coordinator is going to take, but hopefully not too long. I don't know. I think that I've discovered the end of the unknown unknowns, but testing is still going to be.
So just a couple of comments here. I would say, it's totally fine to just blanket extend all of these by some fixed amount. That's what we want to do. I would appreciate like if people can just look at their individual work items and make sure that this chart is reflecting at least our current known state. The second comment was, I followed with Ludo briefly, since he's starting to work on or working on some Clarity features. And the way, at least I would like us to be thinking about, what work to prioritize is try and pick things that would help us de-risk the mainnet launch. And at least through that lens, I think some of the Clarity features maybe take less precedence. And so my suggestion, and I want to get people's reactions to that, is to actually start working on some of the items for phase 4 right now, because they're not blockers. So for example, integrating with the primary Bitcoin testnet is almost an independent thing that we can start working on right now, or fleshing out the upgrade path for Stacks 1.0 to 2.0 transition, and starting to work on that. Those are work items that we have to do that are going to be blockers from mainnet that are not necessarily blocked on phase 3. So those are the things that I would like us to start working on, and curious to get people's reactions. Related to that, I am exploring if we can get help from other folks within PBC to work on some of these things. And the last conversation with the blockchain team, I think some of the core work around proof of transfer itself, doesn't seem like it's the right time or the right strategy to get other people to help out there, because there's too much context. We're already in the thick of things. But some of these other items that are phase 4 related, we could get additional help on. So that's the other reason to explore that. So yeah, curious to get people's reactions.
Dewalker, is there a document somewhere that tracks phase 4 work items?
No, not yet.
Okay, should I just add it here then?
Sure.
Okay.
Yeah, so I think I would be supportive of that, especially like the getting started on work that's like supporting getting Stacks testnet running on the Bitcoin testnet, all sorts of things like that. Would definitely be supportive of that. I think that what I think we should try to do to be like very explicit about sort of how we imagine these phases going is say that in addition to there being like phase 4, rather than phase 4 being like the last phase, like we should imagine that there is going to be a phase of time where we have rough network stability, but we're adding Clarity features. Because what I worry about if we go this strategy is that we're going to have maybe POX working, we will have compatibility on Bitcoin testnet, Bitcoin mainnet, and then we're going to feel like, okay, we should launch mainnet in 4 weeks or something, 3 weeks, and then we launch mainnet without a bunch of Clarity features that I think we would really want to have in mainnet.
Yeah, I definitely hear that. I think the other thing that I don't know where it came up, but I've heard it in a few discussions. Something worth exploring with our broader community even is essentially setting a presetting a date in the future where we would do another hard fork just oriented around Clarity features. So we do a mainnet launch, and then 3 months after that or something, everyone commits to a hard fork to incorporate some pre-agreed upon Clarity features. That might be another thing worth contemplating if that's the path we want to take. I don't know if people have any immediate reactions to that.
I mean, I personally have a very strong aversion to doing hard forks without them being absolutely necessary. I mean, if we feel like it's just going to be a small amount of time between having the final set of Clarity features and mainnet launch, I think we might as well just delay the mainnet launch, right?
Well, I mean, it depends on what's small, right? In the grand scheme of things, 3 months is small, and there are some sort of PBC internal implications for 3 months. Like it could translate to a pretty non-trivial impact to, let's say, our run rate, and so that might be like a PBC internal consideration, but there are considerations. So even though like 3 months, it's a relative thing. It might not be like 3 months might not be a huge time period, but it might still have pretty significant implications. Not suggesting that we should. I'm just offering a counterpoint.
Yeah, I guess we would need to flesh out what those would be. Okay, so let's war game this for a second.
And we can talk about this in the architecture meeting as well. By the way, I just wanted to I don't know if we can resolve this in the next 5 minutes.
Well, I mean, just to like set the tone for that meeting. Do we have like a list of, or at least a strategy for identifying the feature delta between what mainnet Clarity would look like and what our idealized version of Clarity would look like? Part of the reason I'm asking is to try to figure out, like, will this be justification and grounds for doing future hard forks to add Clarity language features? And if so, is that even desirable?
So we have a Clarity Lang like issue board.
Mm-hmm.
I would say like 50% of those issues, if they did not exist at the time of mainnet, we would probably consider Clarity an unusable smart contracting language. Like things like cryptographic primitives, like if they don't exist in mainnet, almost, yeah, it severely limits the number of interesting things that you can do with Clarity's contracts.
Do we this is github.com/claritylang, right?
Yeah.
Maybe I can just link that issue board here.
Yeah, if you just go to projects, just go top right.
Sure. Cool. Sorry. Losing my tab. So a tradition that we do have going just with the current Stacks 1.0 testnet is that we do one hard fork per year to add features. We would probably want to get future hard forks in Stacks 2.0 certified via the SIP process. And we should probably come up with a either a SIP or like either a SIP later or a SIP update to 0 SIP 000 that describes how we would do this. Because one thing that we cannot continue to do that we have been doing with Stacks 1.0 is unilaterally decide, hey guys, hard fork time, new features, take it or leave it. This needs to be something that's far more coordinated with not just miners in our community, but also with like exchanges as well. It can't just be us deciding, hey, new features, take it or leave it.
Yeah, I think everyone's aligned on that, unless you're hearing any disagreement, Jude.
Like even that right there in the broader scheme of the crypto community can be seen as controversial. I know that there are some blockchains, for example, Bitcoin being the traditional one, that adamantly refuse doing hard forks because of the risk of disruption is so high. And then there's even Ethereum, for example, which I guess is like the less conservative version of this. They're still pretty conservative about what goes into hard forks and what doesn't, to the point where they plan out the number of hard forks that will ever occur in the network's existence. They don't just say, okay, hard forks once a year forever. It's we have hard fork for these future milestones, and then when we reach POS, there's no more hard forks. Period. I don't know if I don't know if it's worth plotting out a strategy like that. Where we put some sort of future constraint on our ability to make hard forks, or if we just try to punt it to the SIP process and say if the community wants it, the community can have it as long as they coordinate it correctly. Maybe this could be a topic for the governance call.
Sure, sounds good.
Cool. What are some other things that we should put into phase 4 here?
BNS 2.0.
Yep. We'll also want to have the some file storage and replication implemented as part of that. And we'll need to port the registrar. Figure out who's running it, because I don't think PBC can run it anymore. Are there other sorts of outside of the core blockchain? Are there other sorts of issues we should track, like any more work the Explorer needs or any more work the sidecar needs?
I mean, yes, and that work is getting tracked in other teams. My intention with this table and this document in the beginning was just to stay focused on the core blockchain work, because I think that's going to be the bottleneck, with phase 3 and with mainnet itself. And so I want to stay focused, or that was the original intention. If it's useful to sort of expand the scope to include like everything, whether it's Explorer, Stacks Transaction.js, other places, we could certainly do that, but I would find lesser utility in that.
So the question, are we done with the works on microblocks? Or do we have some remaining items?
Oh yeah, thanks. That's great. They are not finished. We still need to support Poison microblock transactions, and we still need the system to be able to deal with bad streams or fork streams. Thanks for bringing that up, Ludo. I'd completely forgotten.
So maybe a good next step, at least for the phase 4 front, is we do a similar exercise as we did for phase 3 to try and break this down a little bit more, you know, understand dependencies, and maybe do like some rough t-shirt sizing to start to put together an estimate.
Yeah, do we want to just do that asynchronously afterwards?
Yeah, we can do like a first pass async and then follow up either later this week. Yeah, maybe on Wednesday. Just talk through it.
Cool. And we'll add more issues to this phase 4 table as we think of them.
Yep.
Let's see.
All right, I think we're
Right,
at
we're at
time, folks.
So is there anything else, or just call it quits? I think there was one chat here. See you later, Dan.
All right.
All right, cool.
See you later.
See y'all later.
All right. Adios.
Adios.
Thank you, guys.